6.0.0 Introduction to Geometry. We're going to talk about shapes and angles. And let's see, one of our vocabulary words says the first part of the section focuses on plane geometry. It's 2D, mathematical study of two-dimensional shapes like squares, rectangles, circles. In contrast, solid geometry, the mathematical study of three-dimensional shapes, those are spheres, cones, cubes, things like that, covered in this second part, works with three-dimensional shapes. So let's go on here. 6.1 Angles. The construction crafts use the term angles frequently. Angle is a shape made by two straight lines coming together at a point. The space between those two lines is measured in degrees. So an acute angle is less than 90. A 90-degree angle is like at an intersection. It's a square. If you're unfamiliar with that term, a right angle is a 90-degree angle. And if it's smaller than a 90 degree, it's sharper than a 90 degree, it's acute. And if it's larger than a 90, it's obtuse. This is called a straight angle. If you can imagine that there's a point in the center of this hemisphere, the angle goes to the point and then continues on in a straight line, so they call it a straight angle. Here's obtuse, greater than 90. If you have two angles and the two of them add up to 90, they say that they're adjacent. Well, if they're touching, if they share a common side, those two angles are adjacent. Two lines that are crossing at a focal point, the two angles opposite each other across that focal point are opposite angles, and the adjacent angles are sharing a side. So there again, they have the same definitions here. Acute angle, any angle greater than 0 but less than 90. Right angle is an angle that measures exactly 90 degrees. The two lines that form a right angle are perpendicular to each other. This is the angle most used in crafts. You can think of an intersection at a light as being a 90-degree angle or perpendicular to each other. An obtuse angle is an angle that measures more than 90 degrees but less than 180. A straight angle is an angle that measures exactly 180 degrees. Adjacent angles, they have the same vertex and one side in common. Adjacent angles refers to objects that are next to each other. Opposite angles are angles formed by two straight lines that cross, they intersect. Opposite angles are always equal. Let's get into shapes. Figure 25 shows some common shapes in crafts. So here's a rectangle, here's a square, a triangle has three angles, and a circle has, it's the graph of all points equidistant from a focal point, but basically you know what a circle is. So rectangles. Rectangle is a four-sided shape with four 90-degree angles. The four angles always add up to 360 degrees. A rectangle has two pairs of equal sides that are parallel to each other. The diagonal lines of rectangles are always equal to. So if you drew two diagonals, they'd be the same length in this rectangle. All four corners are 90-degree angles, just like a square, but it doesn't have four equal sides. The two sides opposite each other are going to be the same length. A square is a special rectangle with four equal sides. It too has four 90-degree angles that add up to 360 degrees. Each right triangle will have two 45-degree angles and one 90-degree angle. So when you put a diagonal across two of the corners of a square, you're going to form a triangle, and that triangle is going to have two 45-degree angles and one 90-degree angle. And the triangle opposite to it is identical. It'll also have two 45-degree angles and one 90-degree angle. says here, for example, before installing molding along all four walls of a room, measure the perimeter first. If the room is 14 feet by 12 feet, purchase 52 feet of molding. 14 plus 12 plus another 14 plus another 12. So 52. Rope stretchers, we'll go on. Here, triangles, 6.2.3, triangles. A triangle, let's click on the hypertext. It's a closed shape that has three sides and three angles. It's a closed shape that has three sides and three angles. Although the angles in a triangle can vary, they always add up to 180 degrees. So here's a 30, 60, 90 right triangle, and 90 plus 60 is 150, plus 30 is 180. All of the three interior angles of a triangle will always add up to 180 degrees. 60, 60, 60, this is an equilateral triangle. And here we have an isosceles triangle that has two 66-degree angles and a 48-degree angle. And 66 and 66 is 132 plus 48 equals 180. It always adds up to 180 degrees. So here are some special triangles. A right triangle is a triangle that has one 90-degree angle. We use those in Pythagorean theorem for pipe bending and for load calculations or phase correction in three-phase power. Equilateral triangle. An equilateral triangle has three equal angles and three equal sides. An isosceles triangle has two sides that are the same length and a third side that is not. An isosceles triangle has two equal angles and two equal sides. A line used to bisect the triangle, cut it in half from top to bottom, creates two adjacent right angles. A scaling triangle. Scaling triangle has three sides of unequal lengths, so none of them are the same. And then they go on to talk about a circle, and again, we've all seen a circle. It's the graph of all points equidistant from a focal point. Here they're showing that if this circle has a radius of 1 inch, if you were to roll it along the ground, when it makes one full 360-degree revolution, it would have traveled 3.14 inches. That number 3.14 is pi. It's the ratio of the circumference of the circle to the diameter of that circle. We'll see that later on also. Diameter is the measure from one edge of a circle to the opposite edge going through the focal point. The radius is the distance from the edge of the circle to that focal point in the center of the circle. And here they tell us the same thing. Circumference. The circumference is the length of the curved line that forms the circle. The formula for finding circumference is pi times the diameter of that circle. And pi, again, is 3.14. The diameter is the length of a line that cuts across from one side of the circle through the center point to the opposite side of the circle. Diameter is the longest straight line possible inside of a circle. Pi is a mathematical constant value of approximately 3.14. It's very close to 22 sevenths. It's used to determine the area of the circumference of a circle. And then the radius is just half of the diameter. Radius is the length of a straight line from the center point of the circle to any point on the curved line that forms the circle. 6.3.0, calculating the area of a shape. Area refers to the space contained within a two-dimensional object's perimeter. To carpet an office floor or paint its walls, carpet layers and painters must calculate the area before ordering material. So squared measurement units specify the surface area. Inch-pound area measurements include square inches, square feet, square yards. If you take the baseboard of a wall, how long that wall is, and you multiply it times how high the wall is in feet, you'll get the square foot area of that wall. So here are some formulas. It says that the area of a rectangle equals the length times the width. The area of a square equals the length times the width, or one side squared, one side multiplied times itself. The area of a circle equals pi times the radius squared. The area of a triangle equals 1/2 times the base times the height of that triangle. We'll put these to use. We'll see them later. Study problems. The area of a rectangle is 8 feet long and 4 feet wide. Let's take a look at our whiteboard here. There we go. I'm going to move this over just a little bit. There we go. So they meet in the middle there. Okay. So it says that the area of a rectangle equals the length times the width. Number one says the area of a rectangle that is 8 feet long and 4 feet wide. So let's draw. It's always good to draw yourself a picture so you know what you're dealing with here. So here, that's a terrible rectangle, but we're saying our rectangle is 4 feet high and 8 feet wide. So we would multiply 8 times 4, and we would say that this rectangle is 32 square feet. And that's the symbol for square feet. So our answer is C, 32 square feet. The area of a 16 centimeter square is, I believe what they're saying is that it's a square that one side of the square equals 16 centimeters. So we would multiply 16 times 16, and we would get 96 and 160, so 256 centimeters squared. So we would have 256 centimeters squared. If we took 16 and squared it, 16 times 16 is 256. Okay. The area of a circle with a 14-foot diameter. They want to know the area. So what they're saying is this circle has a diameter that's 14 feet across. Well, remember, the area of a circle is pi times the radius squared. So we're going to have to divide 14 by 2 in order to find the radius, which is 7 feet. Excuse me, I just put 7 inches, but 7 feet. So we'll do 7 times 7. That's 7 squared. That's 49 times the number pi. And remember that pi equals 3.14 units. So 3.14 times 49. Let's see if we can do this real quick. I'm going to extend my work page. 9 times 4 is 36. 9 times 1 is 9, and 3 is 12. 9 times 3 is 27, and 1 is 28. And 4 times 4 is 16. 4 and 1 is 5. 4 times 3 is 12. And 1 is 13. 16. 4 times 5. 4 times 3 is 12. Okay. So 6, 8, 13, 5, 1. 1, 2. We've got 2 decimal places, so it's 153.86 square feet. Oh, my math didn't work out. 36, 9, 3 is 12. 9 times 3 is 27 plus 28. 16, 5, 4, 3, 12. Let me take a look at what we've got here. Area of a circle of 14-foot. Oh, I'm sorry, there it is. See, 153.86 square feet. Got the right answer. I was just looking at the wrong question. All right, very good. Let's take a look at the next one here. It says the area of a triangle with a base of 4 centimeters and a height of 6 centimeters. Now, they didn't tell us what the angles are, but that's okay. We don't really need to know the angles. As long as we know the base and the height, we can multiply 4 times 6 equals 24, and the whole thing gets divided by 2. Remember, the area of a triangle equals 1/2 times the base times the height. So I've got 12 centimeters squared. Okay, that's our answer, 12 centimeters. And lastly, it says the area of a rectangle that's 14 meters long and 5 meters wide. We would just multiply 14 times 5. So it should be 70. Okay, let's go on to the next section here. Volume for 3-dimensional shapes. Now remember, when you're talking about volume, you're going to talk about cubic inches or cubic centimeters. This is volume, so it's in 3 dimensions, length, width, and height, depth, as they call it. Okay, when calculating volumes, be sure all measurements are in the same units. For example, a concrete slab has dimensions of 4 feet by 6 feet by 6 inches. So we're going to call that 6 inches 0.5 feet. That will get us all in the same unit. There you go. So it says, before erecting a metal building, concrete workers must pour a slab and install anchor bolts. The structure attaches to the slab by the anchor bolts. Since cement comes in cubic yards of volume measure, the worker must calculate how much cement to use. To determine the slab's volume, multiply its length times its width times its depth. So alternately, multiply the slab's area by its depth. And here we have a 50 feet by 40 foot slab by 6 inches thick. So we're going to use our calculator. I know 50 times 40 is 2,000. So we'll do 50 times 40 equals 2,000 times. Now remember, it's 6 inches thick. That's 0.5 feet. That's a half a foot. So we need 1,000 cubic feet of concrete. 1,000 cubic feet of concrete. Oh, that's what they did here. They took 50 times 40 equals 2,000. Convert 6 inches to feet, so it's a half a foot. 2,000 square feet times a half a foot equals 1,000 cubic feet. So we need 1,000 cubic feet of concrete for that slab. 3-dimensional rectangles, same thing. We're going to do length times width times depth. Cubes. A cube is a special 3-dimensional rectangle. Calculate its volume in the same way. Length times width times depth. But all 3 of those measurements are going to be the same if it's a cube. So you could just say 8 times 8 times 8 in order to get the cubic volume of this, or the 3-dimensional volume of this cube. Cylinders. Now, a cylinder is a circle that has a 3rd dimension. So we first will find the area of the circle. And we know how to do that. It's the radius squared times pi. And then we'll multiply that times the height given in the same unit of measure. So in this case, they're using 22 feet as the diameter and 10 feet as the height. So our calculator will do half of 22. Remember, it's the radius squared. So 22 divided by 2 equals 11. 11 times 11. Here's 11 squared. Here's x to the second. So this is squared. So I'll square my radius, and then I'll multiply times 3.14. And that gives us the area of the circle, 379.94 square feet. We'll take that and multiply it times 10 feet for the depth, and I have 3,799.4 cubic feet. That's how big the volume is of this cylinder, 3,799.4. Let's see how we did. There you go, 379.94, and then they multiplied it times 10, they got 3,799.4 cubic feet. Very good. Oh, it says if necessary, convert cubic feet into cubic yards, because when you buy concrete, you actually buy it by the cubic yard. So they divided by 27 and got 140.72 cubic yards of concrete. Very good. Triangular prisms, same thing. You would do the base times the height of the triangle and then multiply that times 1/2 or 0.5 to find the volume or the area of the triangle, and then multiply that times the depth, which is 2. So 6 times 12 is 72, and we're actually going to divide by 2 and then multiply by 2. So we're going to end up in the same place. It's going to be 72 centimeters cubed. Study problems. Okay. All right, I'm just trying to decide if we want to do these or not. It says a rectangular shape is 5 feet high, 6 feet thick, and 13 feet long. And it has a volume of what? So it's a rectangular solid. It's 5 times 6 times 13. We could do that in our calculator. 5 times 6 is 30 times 13 equals 390 cubic feet. So it's D, 390 cubic feet. I'm going to let you do these others. If you have any difficulty with them, talk with your instructor. If you have any questions, you can always put it in the comments section under the video. I don't have a chat section, so we'll just use the comment section for our chat. Okay, here they're talking about finding an exact 90-degree. If you're trying to make a form and you're not sure, you're out in the middle of a field and there are no reference marks, well, you can measure 15 feet and 20 feet, and between those 2 points should be 25 feet. It's called a 3, 4, 5 right triangle. And you use that a lot in construction to make sure that your angles are a true 90-degree angle. And once you get all 4 of your corners staked off, go ahead and take 2 measurements catty corner diagonally, and they should be the same measurement. If they're not, then you need to adjust your stakes just a little bit in order to make sure that they're the same length. Let's see, what does this say? These are practical applications. Calculate the volume of a sheet of metal duct pipe shown in figure 34. Round it to the nearest cubic inch. So they have this pipe, this duct, and it's round. So we have to remember, we're not calculating volume. We want to calculate square foot area or square inch area of this piece of sheet metal. How much sheet metal is it going to take in order to roll it up and make this duct? And it's 8 inches across in diameter, and it's 13 inches long. So we could say 8 inches times pi. That will give us the circumference of that circle. That'll give us the length of that circle. And then we can multiply that times 13 and get the square inch area. And they said to round it. Oh, I'm sorry, they did say volume. They want to calculate the volume of the sheet metal duct. All right, we can still do that. We'll find the volume by taking half the diameter. That's the radius, and squaring it. So right here where we have this duct, it's 8 inches by 13 inches. I'm going to just make a drawing. It's not going to be the world's greatest drawing. It certainly doesn't rival the Mona Lisa, but there's my duct. We want to know what the volume of that duct is. How much space is there inside that duct? In case the boss is coming and you need a place to hide, you can hide in the duct. Don't do that. All right, so first we're going to take our diameter, 8 inches, and we'll divide that in half to find the radius. So the radius of the duct is 4 inches. I don't know why I'm using my mouse instead of my pen. There we go. So now we're going to find the volume or the area of the circle by doing 4 squared times pi. Remember, the area of a circle equals pi times the radius squared. So 4 squared is 16 times 3.14. Let's see what we get here. 4, oops. There. 4 squared times 3.14 equals 50.24. That's the area of the circle. We'll multiply that times 13 inches to get 653.12. So 653 cubic inches, inches cubed. There we go, 653. Did they give us, oh, they didn't even give us multiple guess here. They just want us to fill it in, 653. How many cubic feet of topsoil must a worker remove before pouring the concrete sidewalk shown in figure 35? The sidewalk must be 4 inches thick and level with the surrounding soil, round to the nearest cubic foot. Okay, so first we need to find the area of the top of the sidewalk, and then we'll multiply it by the depth of the sidewalk, and they said that was 4 inches thick. So here we have 12 feet by 13 feet, and here we have 39 feet, 8 inches by 6 feet. So what I'm going to do is I'm going to break this into 3 different shapes, 3 separate shapes. Let's take a look at these 3 separate shapes. Let's see how closely I can draw. Let's see. This sidewalk. Here's my sidewalk right here. Well, I'm not doing good drawing at all, am I? What's going on here? All right. Here. All right. There. So I'm going to break this into 3 different shapes. I'm going to break it into a rectangle that's 13 feet by 12 feet. And then I'm going to make this one 6 feet by 39 feet 8 inches minus 13 feet, because we're going to stop here. It's 39 feet 8 inches for the whole length. So I'm going to take that off. I'm going to end up with 8 inches, and 9 minus 3 is 6, and 3 minus 1 is 2. So this is 26 feet 8 inches by 6 inches by 6 feet, excuse me. And then I have this little triangle right here that is 6 feet and 4 feet. So we're going to do 13 times 12, and we're going to do 26 feet 8, which is 26 and 2/3 times 6. And then we're going to do 4 times 6 divided by 2. And that'll give me the area of that triangle. So let's find these. Let's get our calculator. There. And we have 13 times 12 is 156. 156 square feet. And then we have 26.67 times 6, and that's 160.02. I'm going to write 160 and ignore the 0.02, and then 4 times 6 is 24 divided by 2 equals 12. So I keep hitting that button. So 6 plus 2 is 8, and 5 and 6 is 11, plus 1 is 12, and that's 1, 2, 3. So 328 square feet. Now, they said it was 4 inches thick. So I'm going to take this and I'm going to multiply it times 1/3 of a foot. So I'm going to divide this by 3, basically 328 divided by 3. Let me clear my calculator and do 328 divided by 3. That gives me 109.3. And what did they say about rounding? They said round to the nearest cubic foot. So I'm going to round to 109 cubic feet. That's my answer, 109. There, 109 cubic feet. Very good. All right. Let's go on from here. Let's see what else we have here. Section 6 review. Angle of 66 degrees is an acute angle. It's less than 90. What is the difference between the circumference and the perimeter? Circumference applies only to shapes with angles, while the perimeter applies only to circles. I don't like that answer at all. The circumference is never larger than the perimeter. The perimeter represents 1/2 the circumference. Where did they come up with these answers? The perimeter applies to all shapes, while the circumference applies only to circles. I would say the answer is B. The perimeter applies to all shapes, while the circumference only applies to circles. Calculate the area of a rectangle. That's 27.3 meters times 9.3 meters. So we just multiply those together and find the square meter area of that rectangle. So we know it's not A and we know it's not D because they're doing cubic, and they're not asking us for cubic. They're asking us for area, which is 2-dimensional. So we'd have to find out if what these would be. 3 times 3 is 9. Well, I'm not going to do it. Use your calculator and come up for an answer with an answer for 3 and 4. I believe this concludes our study on math for section 00102. So I hope that you got a lot out of it, and I'll see you on the next video. Hey, this is Brian Young. If you liked my video, please give it a thumbs up and consider subscribing. I'll see you on the next video.